All right, welcome back. I am still trying to solve midterm or final exam of term 211. And this is the second part of question 2, okay, where we have this ALU question. So we are required to design an arithmetic logic unit whose inputs, okay, are two 4-bit unsigned binary integers x and y, okay, and it has two control signals f0 and f1, right, to choose the function, and the output is a 5-bit unsigned binary integer z, okay. So the this is like black box diagram of the ALU, and this is the function table, okay. So when the function is 0, 0, the ALU produces twice x or 2 times x. When it is 0, 1, we have x plus 1. When it is 1, 0, we have the minimum of x and y, and when it is 1, 1, we have the maximum of x and y. Okay, so we need to do a circuit, okay, that gives us the minimum and the maximum, all right, of x and y. We need to do a circuit that adds 1 to x. We need to do a circuit that multiplies x by 2. Multiplication by 2 is the easiest because it's just putting a 0 in front of x, okay. Since the numbers are unsigned and we are expecting z to be of 5 bits, okay, so we expect to have the carry as part of the result, okay. So yeah, so basically one way to solve this is to have like a multiplexer, okay, a 4-to-1 multiplexer that selects the operation based on the function, okay. So when x is when the functions are 0, 0, so let me just draw a big 4-to-1 multiplexer, okay. So here's S1, S0, and these are hooked up to F1 and F0. For input number 0, and this is Z, yeah, Z, which is the output, and it is 5-bit, okay, 5-bit. This is a 5-bit 4-to-1 mux, okay. For input number 0, which is also 5-bit, we have x multiplied by 2, so which is x concatenated with a 0, okay, x concatenated with a 0, all right. And for input number 1, we have x plus 1, so we have an adder, okay, an adder. Yeah, actually we are allowed to use what we call incrementer, okay, so I'm going to use an incrementer, okay, an incrementer for, so we have incrementer, right, and it takes x and it produces the incremented value and a carry out, right? This is x plus 1, and this is the carry out, okay. So I concatenate these two together, 5-bit, okay, and this is going to be my x plus 1, okay, x plus 1, all right. So this is the second one, the second input. The third input is coming from the max and min, so this is number 2, and this is number 3, okay, number 3, and this is going to be the minimum, and this is going to be the maximum. So minimum. So we have a comparator here, magnitude comparator. magnitude comparator. And we are producing, for example, this is A and B, right? And I'm going to hook up an X and Y, 4-bit and 4-bit. And as a result, I'm going to produce A greater than B. Okay. And so if A is greater than B, then B is the minimum here. Okay. So here we want the minimum first. So we have a multiplexer that chooses between 0 and A. Remember, we need 5 bits. Yeah? We have to concatenate a 0 to the left of the number. Okay, so this is a 5-bit. Okay, and this is a 2-to-1 5-bit, 2-to-1 max. Okay, and this is line number 0, and this is line number 1. This is A. Okay, and this is 5-bit for B. Okay, I forgot the 0 here. And then we hook it up to here. Okay, and yeah, what about the selection line here? Okay, we need the minimum. Okay, so here, this, if this is true, okay, then if this signal here is true, then I'm going to select B, which means that B is the minimum. Okay, and if it is false, then I'm selecting A, which means A is the minimum. Okay. Similarly, for the other one, which is basically line number 3 of this. So this is, again, this is 5-bit. Okay, and okay, we have like another multiplexer here. Okay, 0 and 1. Also, this is a 5-bit 2-to-1 max. Right, and for the selection line, I'm going to feed it with A less than B. Okay, I want B to be, if B is the larger number, then this is going to be, and if B is larger, then this is going to be a 1. Okay, so I need to hook B to 1 and A to 0. Okay. And there is your 5. Okay, this is going to be 0, A and 0, B. All right, so this is 5-bit and this is 5-bit. So this is your circuit. Okay, simple as that. All right. Okay. Let me see if this question has more. Okay, let me stop here to continue in another video.